Hello everyone, myself Maruthi, welcoming you all to this math video session. In this video, I'm going to teach a topic from mathematics, that too trigonometry, a beautiful sum. Of course, the question is given like this. So what it says, if tan theta plus secant theta is equal to 2 by root 3, find the value of sine A. So it's a tricky one, we'll figure it out that. So what he says, tan A plus secant A is equal to 2 by root 3 and he's asking us to find sine A. Fine. Let's get connected to that. So what I'm doing, I have taken the question. Given is equal to tan A plus secant A. I like to call this as equation 1. Boom. Right. The one what he has given, I like to consider as equation 1. Now what I started thinking means, I got tan, I got secant. Right. Okay. Now he's asking something else, something like tan. No way related to this. Okay. So what are the relations what we are having? So generally fundamental identities, square identities, reciprocal identities, quotient identities. These are the general stuff what we use in this level. Okay. So what are the two tricks what he has given? He has given tan and secant. By seeing this one, I started connecting to the identities. Then I have come across square identity. So the square identity 2 is nothing but secant square theta minus tan square theta is equal to 1. Okay, so then I started thinking that why can't I use a square identity? Okay, so now why? Because secant and tan are the two things related. Now moreover, what is coming first? We are getting secant first. Therefore, so the given question is tan theta plus secant theta. Wantedly I changed it as secant theta. Okay, secant A plus tan A. Wantedly I did that. Why? Because when I am planning to use second square identity, definitely we need secant first. Therefore I made it, and this is nothing but 2 by root 3. I like to call this as equation 1. Never mind, the same thing, equation 1. Okay, now I'm going for the formula. So what's that? We know the square identity. We know that according to square identity 2, just now I said secant square theta, secant square A minus tan square A equals 1. This is the formula what we are having. This is the general square identity 2. Now, as this is in the form of square identity, I like to convert in terms of algebraic stuff. Right. Likewise, so I am making this as whole square minus whole square is equal to 1. What does it mean? I have taken this as a secant A whole square and this as tan A whole square. Cool. Why did I do like that? Why? Because I like to use algebraic formula. Why you are planning to deal with algebraic formula means in the answer whatever he is asking, we are having only sine A. We don't have something like sine square A. We don't want squares here. Right, we want to eliminate that. So how can you eliminate a square into a non-square? Right, without square, what can you do? Then I started thinking a formula. So what's that formula? If you generally come across anything like a square minus b square, we can write it as a plus b into a minus b. This is the logical stuff what you have to remember. Right, why? Because if you check it out, it is in the form of a square minus b square. The squared one we are able to write as non-squared one, the degree 1. Okay, that's the cool thing. So the given question, I like to convert it as something like a plus b into a minus b is equal to 1. Alright, what comes under A? This is nothing but A and this is nothing but B for us. So what we are planning to write, we like to write in terms of A plus B into A minus B. That is secant A plus tan A. Okay, that's the first one. In the same way, secant A minus tan A. That is what I am planning to write. So see here, we are having squared stuff here, whereas we are having non-squared stuff. Yes, I got it. It means we are moving step by step in that procedure now. After coming over here, I have seen that secant theta plus or secant A plus tan A can be written as 2 by root 3. Cool, it's already given there. So why can't I plug in that value in the given question there? So what I am doing, so in the place of secant A plus tan A, I'm writing it as 2 by root 3. 2 by root 3. Of course, the leftover is secant A minus tan A is equal to 1. Okay, so why did you write the 2 by root 3 means straight away from equation 1? From equation 1, that's given. Its equation 1 is given, from where I have taken it as 2 by root 3. Now what is we are having now? Secant theta minus tan theta. So what I am doing means secant A minus tan A is equal to 1. We are having there. The 2 by 3 whatever we are having, I am transforming to the other side. If you transform it to the other side, the basic stuff what we all know, that reciprocates itself, that is into root 3 by 2. That's the cool stuff. So what I have done, secant theta minus tan theta, 2 by root 3, if it is transformed to the other side, it reciprocates itself. 2 by root 3, it came this side and became root 3 by 2. Alright, now we can straight away we can multiply the top to top and bottom to bottom. If you check it out, it's nothing but secant A minus tan A equals root 3 by 2. I like to call as this, we are calling it as equation 1. I like to call this as equation 2 now. Yep. So we are ready with the two equations, equation 1 and equation 2. What we are planning to do with these two equations? Let's start solving equations 1 and 2 by addition. Let's add them. Let's add them and solve it. What's the first equation? What we have? It's nothing but secant A plus tan A is equal to 2 by root 3. That is the first equation. What's the second equation what we have? It's nothing but secant A minus tan A, it's nothing but root 3 by 2. These are the two equations what we have. So what we are planning? We like to solve it by addition, right? Now when we are simplifying it, if you observe it, this is plus tan A, this is minus tan A. It means this is plus 1 and this is minus 1. As you all know, plus 1 and is minus 1 is nothing but 0. Fine, it's cool. Therefore, I like to cancel this stuff. Okay, now what is left over here? If you check it out here, this is nothing but plus 1 and this is nothing but plus 1. Totally how much? It's nothing but plus 2 secant A equals, here we are having 2 by root 3 and here we are having root 3 by 2. It's cool. So 2 by root 3 it went to the other side, root 3 by 2. It's nothing but root 3 by 2. Now I have to add these two stuff. So now let me add them up. 2 secant A equals, let me take LCM for that, 2 root 3. Cool. Now, why did I take 2 root 3? Well, because they doesn't go in the same table. Therefore, whatever is there, take both of them. Now, root 3, how many times does it go? Whenever we are checking out whatever is present there, we have to close that. Root 3, close that. What is left over? 2. Now, 2 into 2, it's nothing but 4 plus, fine. How many times 2 goes? Whichever we are checking, close that. And what is left over? Root 3. You multiply that with the top. Root 3 into root 3, it's nothing but 3. Okay, now what we got? 2 secant A equals 4 plus 3, 7 by 4 root 3. You got it. Now, what we want? Just let's go for that. What's that doing that? It's nothing but secant A, 7 by, the 1, 2 is multiplying there. If it goes to the other side, it goes to the denominator. 2 into 4 into root 3. Now, secant A, we got it as 7 by 8 root 3. Yes, we got the value of secant. Okay, now what he's asking actually, he is asking us to find sin A. But what you got now, it's nothing but secant A, right? Now, how to go from secant to sin? So I started thinking in terms of what's the relations what we have. I have one relation. From secant, I don't have straight away relation to sin. But from secant, I have a relation to the cos. That is nothing but multiplicative relation, right? Let's go for that. Right. So we know that what's the formula we have? We know that according to reciprocal identity 2, what's that? We are having cos theta into secant theta. Cos theta or cos A into secant A is equal to 1. Fine. Now, what is cos A now? Cos A is nothing but 1 by secant A. But what is secant A we got? We got 7 by 8 root 3. So, which is nothing but 1 by 7 by 8 root 3. What's that? We are talking about cos. So, cos A, now I like to flip this one to the top. If this one which reciprocates it, it's nothing but 8 root 3 by 7. Okay, so what did you get now? So we got cos by using what? By using, right, reciprocal identity 1, I got to know what's the value of cos. But ultimate target is not cos. We like to go for sine. We will find it. Let's get back to this. 2 secant A is equal to 7 by 2 root 3 what we are having. So what we are planning means we need only secant A. Right, secant A is nothing but 7 by 2 root 3 is already there. The 2 what it is multiplying there, we are pulling it back here, it's nothing but again, it's in the numerator, if it comes here, it is in the denominator. Now, secant A, we are having it as 7 by 2 2s are 4 root 3. This is what we got from here now. So, from what we want actually, we need sine A, right? Where we have reached, we got cos. Okay, now I started thinking, what is required? We need only sine, but where we are having secant. So, how to get back to secant? As we need something like our ultimate target is sine. Yes, we need sine. So, our ultimate target is nothing but sine. We have to find. So, how to? So, to reach sine, right, where we are at the secant. Okay, we don't have straight relation with the sine, but in between we are having cos. Okay, from secant I like to go to cos by using reciprocal identity 2. Right, from there onwards I like to reach a sine by using square identity 1. That's the plan I'm having now. So let us use that and get back to the formula now. So let's go for the first one. So what is the thing what I am planning to use? Reciprocal, right? From reciprocal identity 2. What's the formula we have? We are having something like cos theta into secant theta is equal to 1. Okay, what we want, our plan is from secant first I like to reach to cos. So I am leaving cos here, cos A, as we are dealing with A, is cos A is equal to 1 by secant. Okay, now cos A we are having, but cos secant A we have already got the answer. Therefore 1 by, so what's the value of the secant here? 7 by 4 root 3. From where did you get? From here. Okay, now as we want cos A, just reciprocate it to the top. So 7 by 4 root 3, it becomes 4 root 3 by 7. So where did we reach? Right, we have reached to cos. But is our target cos? No, our target is not secant, our target is not cos. We need sine. Okay, how sine is related? From here we reached here, from here we like to go to the other step. So, what is what we are having? So, from square identity 1, so from square identity 1, what's that? Sine square A plus cos square A equals 1. This is the formula what we are having. So, what is your goal? It's nothing but sine. So, what I am doing, I am leaving the sine square here, sine square A here, which equals, already 1 is there, if this one goes there, it's nothing but 1 minus cos square A. Fine. Do you know cos A now? Yes, I know it. Therefore, 1 minus, I'm keeping in the bracket there. So, what's the value of cos here? It's nothing but 4 root 3 by 7. Cool. I repeat. So, from we have reached secant. From secant, we reached cos. From cos, we like to go to sine with the help of square identity 1. Okay, so now let me simplify that. 1 minus the square goes to all the three numbers there. We are cool. So 4 square, it is nothing but 16. Root 3 square is nothing but root 3 into root 3, which is nothing but 3. Yes, by 7 square is nothing but 49. Let me simplify that. 49. If I take LCM in 1 goes in 49. 49, 49, 1 6 49 minus 16 3s is 48. So it's nothing but 1 by 49. Cool. What's that? It's nothing but sine square. Right, sine square A. But our ultimate target is not sine square. We need sine A. Right, sine A is nothing but under root 1 by 49. Cool. So what is 1 by 49? Can I tell it as 1 by plus or minus 7? Yes, but the thing is, he didn't mention whether it is in the first quadrant or which quadrant, but obviously we take in the first quadrant. Therefore, we can straight away go there. Therefore, sine A equals 1 by 7. This is the goal. So, cool guys, we have taken two equations. The first equation he has given 2 by root 3. Second equation we have got from using the square identity sine square theta minus tan square theta is equal to 1. Right, we have opened in terms of a plus b into a minus b. We got the second equation. We cancelled it. We got the secant. From secant by using the reciprocal identity to reach cos. From cos go to sine. This is a beautiful way of reaching the target. Hope you did it. In this channel I have been placing both math and science videos.